So how is the arrow's motion perceived?
Finally, one of the most interesting and insightful paradoxes is attributed to Socrates thus. It is called the Socrates paradox. It is based on Socrates' statement, "One thing I know is that I know nothing."
How are modeling and simulation used in engineering?
Modeling and simulation have become an essential part of engineering on both a small and large scale. Because building any size of structure takes time and money, engineers often develop a mathematical model, a set of equations that describe what may happen to a structure if it is built the way it is represented by the model. Using a computer, or graphic, representation gives the engineers a three-dimensional view. For example, before the Space Shuttle was built, engineers used mathematical modeling to simulate what the craft would look like in 3 dimensions. In this way, the engineers learned how the shuttle would fly, how strong the heat-resistant tiles had to be in order to re-enter the Earth's atmosphere, and even how to maneuver the shuttle under various conditions as it landed. The computer was the only way to solve such problems without real-life testing. It quickly and easily solved a plethora of mathematical equations, especially calculus and differential equations that represented how the shuttle would take off, fly, and land.
What is an ion?
Scientists know that atoms can gain or lose electrons, thus acquiring a negative or positive electrical charge, determined by the number of protons minus the number of electrons. For example, if there are 4 protons and 6 electrons, the net charge is -2, often called the valence. An ion is an atom or group of atoms that takes on the net electric charge, and can be positive, cation, or negative, anion. Based on the mathematics of losing or gaining electrons, ions can be formed or destroyed. This is one example of where math comes in handy in chemistry.
Are advances in technology fundamental to our understanding of materials?
Yes, advances in technology are truly fundamental to our understanding of materials, and vice versa. For example, transistors and superconductors were developed by understanding the mathematics of the materials that make up these objects. Math and materials science together have also advanced technology used in infrastructure, such as highways and overpasses, aerospace, such as satellites and shuttles, and microelectronics, such as those found in automobiles. Today, the need to describe material behavior resulting from physical interactions is forcing scientists to develop new mathematics. In fact, materials science has evolved to the point in which researchers from physics, engineering, and applied mathematics are working together on common problems.
How is the amount of rainfall measured?
The amount of rainfall liquid precipitation that falls to the surface is measured by a rain gauge. The most commonly used freestanding rain gauge is a cylinder with increments, most often in inches, inscribed on the outside of the tube. It is put in an area that is not obstructed by buildings, trees, or other tall structures that can impede the collection of rainfall. The rain gauge can also measure snow, but added steps are needed to calculate this. In this case, a rain gauge measures the liquid equivalent of snow. This is why meteorologists will often say that a snowstorm that produces 10 inches, 25.4 centimeters, of snow will have a liquid equivalent of 1 inch, 2.54 centimeters, of rain, or a ratio of 10:1. But this generalization can be tricky. If the weather system is super cold, such as an Arctic air mass over Canada and the northern United States, the below freezing temperatures might create more than 10 inches of snow per inch of rain. Meteorologists often call this the fluff factor, because the snow seems fluffier due to the fact that there is more air between the snow crystals at much colder temperatures. In fact, in very cold air the snow-to-liquid equivalent ratio can be 15, 20, or even 30:1. For more about weather and math, see Math in the Natural Sciences.
What type of numerals did the Egyptians use?
By about 3000 BCE, the Egyptians had a writing system based on hieroglyphs, or pictures that represented words. Their numerals were also based on hieroglyphs. They used a base 10 system of numerals, 1 unit, 110, 100, and so on to 1 million. The main drawback to the system was the number of symbols needed to define the numbers.
What were some early counting devices?
The very earliest counting devices were human hands, with the fingers used as digits. There were limitations to this device, though, especially since each hand only has 5 fingers. To count more items, some cultures assigned even larger counts to other parts of the body. Such counting methods became tedious, so merchants and others who needed to keep track of assorted items turned to nature, using sticks, stones, and bones to count. Eventually, devices called counting boards were developed. At first, the counting boards were simple, usually entailing drawing lines with fingers or a stylus in the sand or dirt.
What is a fallacy?
A fallacy is an incorrect result in this case. One arrived at through misleading reasoning when examining a logical argument. One of the more common fallacies in logic is believing incorrectly that if P implies Q is true, then Q implies P is also true. The idea of such invalid arguments was well known in the past, with Greek mathematician Aristotle's syllogisms. An argument was valid if it adhered to all the laws. To be false, it only needed to break one law. Euclid, another Greek mathematician, was known to have written an entire book on fallacies in geometry, but the book has since been lost.
What is scientific notation?
Scientific notation is a way of making larger and smaller numbers used in the scientific field easier to write, read, and take up less space in calculations. Scientists generally pick the power of 10 that is multiplied by a number between 1 and 10 to express these numbers. For example, it is easier to write 0.0002333452 as 2.333452 x 10 to 4. For more about scientific notation and power of 10, see Math Basics.
What is an expression in mathematics?
An expression in mathematics is a statement that uses either numbers, variables, or both. For example, the following are all mathematical expressions: y4645x x74 plus 5x, 32, x plus 4x. 7x. In order to write an expression from a written mathematical problem, one has to interpret the text. For example, if one person weighs 100 pounds and another weighs y pounds, the expression for their combined weights would be 100 plus y.
What was the driving force behind the development of accurate clocks?
The true driving force behind accurate clocks began around the 16th century in relation to finding longitudinal measurement. As countries began to explore the world, an accurate way of telling a ship's position became a critical problem. With one time standard around the world, and clocks to tell those times, longitude, and thus position, could be determined. This would not only mean an increase in exploration but also wealth for the sponsoring country.
How did the first standard metric measurements evolve over time?
The first standard metric units were developed by 1799, the meter was defined as 1/10,000,000th of the distance from the equator to the North Pole. The liter was defined as the volume of 1 cubic decimeter, and the kilogram was the weight of a liter of pure water. The standards metamorphosed over the years. For example, the first physical standard meter was in the form of a bar defined as a meter in length. By 1889 the International Bureau of Weights and Measures, BIPM, or Bureau International de Poids et Mesures, replaced the original meter bar. The new bar not only became a standard in France, but copies of the newest bar were distributed to the 17 countries that signed the Convention of the Meter, Convention du Meter, in Paris in 1875. The accepted distance became 2 lines marked on a bar measuring 2 cm by 2 cm in cross-section and slightly longer than 1 meter. The bar itself was composed of 90% platinum and 10% iridium. But it was only a standard meter when it was at the temperature of melting ice. By 1960 the BIPM decided to make a more accurate standard, mostly. This was done to satisfy the scientific community's need for precision. The new standard meter was based on the wavelength of light emitted by the krypton 86 atom, or 1,650,763.73 wavelengths of the atom's orange-red line in a vacuum. An even more precise measurement of the meter came about in 1983, when it became defined as the distance light travels in a vacuum in 1/299,792,458 second. This is the currently accepted standard.
How do you reduce a fraction?
To reduce a fraction, there are 3 general steps: factor the numerator, factor the denominator, and cancel out the fractional mixes that have the value of 1. The leftover number is the reduced fraction. For example, to reduce 16/56, the reduced fraction equals 2/7.
What was the Pythagorean society?
Greek philosopher and mathematician Pythagoras of Samos, c. 582 c. 507 BCE, not only contributed the Pythagorean theorem to mathematics, but also started a group, some say called the Pythagorean Society. The school he founded stressed the necessity for people to be well-rounded and also taught reincarnation and mysticism, making it similar to or perhaps influenced by the earlier Orphic cult. The fundamental belief of the Pythagoreans was that all is number, or that the entire universe, even abstract ethical concepts like justice, could be explained in terms of numbers. In fact, Pythagoras was so enamored with the concept of numbers that his beliefs were centered around the premise that the entire universe was based on a mathematical algorithm. But the society also had some interesting non-mathematical beliefs, too. Those in the inner circle of the society were called the mathematikoi, the lived permanently with the other Pythagoreans, had no personal possessions, and were vegetarians. Those in the outer circle of the society were known as akosmatics. They lived in their own houses and only came to the society gatherings during the day. Even women were allowed to join, some of them becoming famous philosophers. Although Pythagoras is thought to have written many works, the secrecy of his school and its communalism has made it difficult to distinguish between the works of Pythagoras and those of his followers. For more information about Pythagoras and the Pythagoreans, see above and History of Mathematics.
What are some details of Jean-Baptiste Fourier's life?
The accomplishments of French mathematician and physicist Baron Jean-Baptiste Joseph Fourier. 1768 to 1830, prove that not all famous mathematicians did just math. Fourier was a teacher, became involved in the messy French Revolution, and was arrested for his views and imprisoned in 1794. For a time, he even feared the guillotine, but political changes resulted in Fourier being freed. By 1798 Fourier joined Napoleon's army in its invasion of Egypt as a scientific advisor. After Napoleon lost the Battle of the Nile to Nelson and was confined to Malta, Fourier continued his work in Egypt, establishing educational facilities there and carrying out archaeological explorations. Back in France with Napoleon in 1801, he supervised the draining of the swamps of Bourgoin and the construction of a highway from Grenoble to Turin. He also spent time writing Description of Egypt, a book that Napoleon edited, and included some historical rewrites. By the second edition of the book, Napoleon himself would be completely edited out of the text. As if he wasn't busy enough, during this time Fourier wrote his now famous 1807 paper on the propagation of heat in solid bodies, a mathematical work on the theory of heat that presented one of his major contributions, the Fourier series. But it was an uphill battle to get approval from his peers. In 1811 he submitted his 1807 ideas for a mathematics prize, along with additional work on the cooling of infinite solids and on terrestrial and radiant heat. Only one other entry was received, making Fourier's work the obvious winner. Finally, by 1822, he published his 1811 essay, making the techniques of Fourier analysis available to everyone. To this day, the functions that he worked out have a multitude of applications in engineering, science, and mathematics.
What is a sample space?
In any experiment, there are certain possible outcomes. The set of all possible outcomes is called the sample space of the experiment. Each possible result is represented by one and only one point in the sample space, which is usually denoted by the letter S. To each element of the sample space, or to each possible outcome, a probability measure between 0 and 1 is assigned, with the sum of all the probability measures in the sample space equal to 1.
Who invented catastrophe theory?
Catastrophe theory, or the study of gradually changing forces that lead to so-called catastrophes or abrupt changes, was popularized by French mathematician René Thom. 1923 to 2002, in 1972. Unable to use differential calculus in certain situations, Thom used other mathematical treatments of continuous action to produce a discontinuous result. Although it is not as popular as it once was, it is often used in biological and optical applications.
Who first calculated the distance from the Earth to the Sun and Moon?
Around 290 BCE, astronomer and mathematician Aristarchus of Samos, c. 310 BCE to c. 230 BCE, used geometric methods to calculate the distances to and sizes of the Moon and Sun. Based on his observations and calculations, he suggested that the Sun was about 20 times as distant from the Earth as the Moon. It is actually 390 times. He also determined that the Moon's radius was 0.5 times the radius of the Earth. It is actually 0.28 times. The numbers differ not because Aristarchus had no geometric knowledge, but because of the poor instruments used at that time. These calculations were not the only contribution made by Aristarchus. He was also the first to propose that the Earth orbits the Sun many centuries before Nicolaus Copernicus, see below. This concept was radical for his time, because it conflicted with geocentric religious beliefs and Aristotle's principle that all objects move toward the center of the Earth.
What are some examples of algebraic equation solutions?
The following lists some simple solutions to selected algebraic equations. To solve for the equation 4x4 equals 12, add 4 to each side. 4x equals 16, then divide both sides by 4, x equals 16/4, then solve for x. X equals 4. To solve for the equation, x plus 3, 2, 4x equals x1, 2 plus 3. Expand each side by first doing the operations within the parentheses. X2 plus 2x plus 9 equals x2, 2x plus 4, then add x2 to each side. Another way of subtracting 2x plus 9 equals dash 2x plus 4, then add 2x to each side. 4x plus 9 equals 4, then add minus 9 to each side. 4x equals minus 5, then multiply each side by January 4th, divide by 4x equals minus 5/4.
What is game theory?
As the words imply, game theory has to do with the mathematics and logic used in the analysis of games or the situations that involve groups with conflicting interests. Another way to look at a game is as a conflict that involves gains and Losses between two or more opponents who all follow a set of formal rules. In particular, game theorists study the predicted and actual behavior of individuals in specific games, as well as the optimal strategies used in the games. Thus, the principles of game theory can be applied to games such as cards, checkers, and chess. Or, they can be applied to real-world problems in economics, politics, psychology, and even warfare. For example, game theory is used to determine optimal policy choices of presidential candidates, or even to analyze Major League Baseball salary negotiations.
What is a polygon?
The word polygon means many angles, Greek poly for many, gonies for angle. It is a closed figure in a plane made up of line segments, straight with no curves, that intersect only at their vertices, endpoints. In other words, no sides, lines, can touch each other except at endpoints. A polygon has the same number of sides as it has vertices.
How is statistical data presented?
There are many ways to present statistical data, all of which involve graphical means to translate the results of statistical tests. A histogram is a graphical representation of a distribution function using rectangles. It is also most often constructed from a frequency table, see below. The widths of the rectangles usually indicate the intervals into which the range of observed values are divided. The heights of the rectangles indicate the number of observations that occur in each interval. The shapes of histograms vary depending on the chosen size of the intervals.
How did our present day become divided into hours, minutes, and seconds?
Divisions into hours, minutes, and seconds probably began with the Sumerians around 3000 BCE. They divided the day into 12 periods, and the periods into 30 sections. About 1000 years later, the Babylonian civilization, which was then in the same area as the Sumerians, broke the day into 24 hours. Europe around 20,000 years ago recorded days between successive new moons. Another hypothesis states that the measurement of time dates back some 10,000 years, which coincides with the development of agriculture, especially in terms of when to best plant crops. Still others point to timekeeping evidence dating back 5,000 to 6,000 years ago around the Middle East and North Africa. Whatever the true beginnings, most researchers agree that timekeeping is one of those subjects whose history will probably never be accurately known.
What are some life questions you can figure out using math?
There are many questions you can explore about your own body and age with mathematics. For example, approximately how many Sunday nights can you expect to sleep until you are 100 years old? Just take 100 years, minus your current age, and multiply that result by 52 weeks in a year with a Sunday. For example, if you are 25, the answer would be 125 x 52 equals 3. 900. How many of those will be good night's sleep is up to you. To calculate the number of times your heart has beaten since you were born, you need the help of a watch or clock. First, time your heartbeats per minute. To find out how to count your pulse, see Everyday Math. Then multiply beats per minute x 60 minutes, in an hour, x 24 hours, in a day, x 365.25 days, in a year, x your age. For example, 72 heartbeats x 60 x 24 x 365.25 x. A person who is 30 equals 1,136,073. 600 beats since the person was born. Of course, this is an approximation, since the heart usually beats slower at night. And it speeds up when you see the bill for your latest car repair. Figuring out how much air you breathe during a lifetime is another fun mathematical calculation. If you optimistically decide you want to eventually be 100 years old, and the average person inhales about 1 pint, or 0.47 liters, of air per breath, you can do the math. First, take the number of breaths you take while at rest per minute, say about 21 per minute. X 0.47 liters x 60 minutes x 24 hours x 365.25 days x 100 years old equals 519,122,520 liters. Again, this is only an approximation.
Were there any problems with the Babylonian numbering system?
Yes. One in particular was the use of numbers that looked essentially the same. The Babylonians conquered this problem by making sure the character spacing was different for these numbers. This ended the confusion. But only as long as the scribes writing the characters bothered to leave the spaces. Another problem with the early Babylonian numbering system was not having a number to represent 0. The concept of 0 in a numbering system did not exist at that time. And with their sophistication, it is strange that the early Babylonians never invented a symbol like 0 to put into the empty positions in their numbering system. The lack of this important placeholder no doubt hampered early Babylonian astronomers and mathematicians from working out certain calculations.
Can there ever truly be a balance in supply and demand?
As most people know from the fluctuating prices of gas, food, and other staples, and thanks to the ever-changing variables in the mix such as war and natural disasters, there is rarely, if ever, a good balance between supply and demand.
What are some first-order differential equations?
A first-order differential equation is one involving the unknown function y, its derivative y, and the variable x. As seen above, these types of equations are usually referred to as explicit differential equations. There are several types of first-order differential equations, including separable, Bernoulli, linear, and homogeneous. For explanations of the last two, see below.
What are the main parts and types of computers in use today?
The basic parts of a computer are the central processing unit, CPU, memory, a keyboard and other optional input devices such as a scanner, and output devices such as a screen, a printer, and audio speakers. The biggest differences between the various types of computers are the amount of memory and speed of the machines. It's also easy to see why the word computer has so many connotations. They vary greatly, but include the following basic types, which are based mostly on the size and number of people who can simultaneously use the machines. The mainframe is considered the largest and most powerful general-purpose computer system. It is usually used to fill the needs of a large agency, company, or organization, because it uses hundreds of computer terminals at the same time. Supercomputers are sophisticated machines designed to perform complex calculations at maximum speed. Because of their speed and the great amount of data they can work through, they are most often used to model huge dynamic systems with many variables, such as weather patterns and groundwater flow. Microcomputers are usually subdivided into personal computers, or desktop computers, and workstations. Oftentimes, microcomputers are linked together in a local area network, LAN, or by joining the microprocessors in a parallel processing system. This allows smaller computers to work in tandem, often giving them comparable power and computational abilities to mainframes. Familiar to many people today are notebooks and laptops, which are very similar. Laptops are small enough to fit on a person's lap. Notebooks are usually a bit smaller and lighter than a laptop. The newest ones often have the same capabilities as a desktop computer.
What is the Monty Hall problem?
Let's Make a Deal, a once popular television game show with host Monty Hall, who was the master of ceremonies from 1963 to 1986, is the origin of the Monty Hall problem. The same type of problem is also represented in a card game called 3 Card Monty. The Monty Hall problem is similar to the show. A contestant is given a choice of 3 doors. Behind one is a car, behind the other 2 there is nothing. The host asks the contestant to pick a door. After the pick, the host opens one of the unpicked doors. One the host knows is empty. The host then suggests a switch. The big question, and the problem, becomes, does the contestant switch his or her choice or keep the originally chosen door? The mathematical, statistical answer is yes, switch the doors. Why? Because the original probability that the contestant picked the correct door does not change. It is still 1/3. But if the contestant does switch, the probability becomes 2/3. Most people believe that once one of the doors is eliminated, the probability between the remaining doors becomes 50-50, but it does not.
What is a nonlinear differential equation?
From above, we know that linear equations have specific rules. For example, the unknowns y, and so on, will never be raised to a power more than 1, they will not be in the denominator of a fraction. Y times y is never allowed, because 2 unknowns multiplied together is, in a sense, a power 2 of unknowns, and they won't be inside another function, such as a sine. But a nonlinear equation is much different, allowing for powers of 2, y equals y2. Multiplying differences, y equals x, and even being inside another function, y equals x sin y. Thus, the nonlinear equations are not as easy to solve as linear differential equations. But that does not mean they lack importance. In fact, because nonlinear equations are more realistic in describing real-life problems, they are much more interesting, and challenging, to mathematical and scientific researchers in many fields.
Are there some numbers that are used more frequently in societies than others?
There are numbers that appear to be used more frequently by some cultures than by others. For example, according to The Secret Life of Numbers by Golan Levin, al. 2002, certain numbers, such as 212, 911, 1040, 1492, 1776, or 90,210, occur more frequently. Because they are used to identify such entities as phone numbers, zip codes, tax forms, computer chips, famous dates, or even television programs that figure conspicuously in Western culture. Picking the powers of 10 also reflects the standard base 10 numbering system used in the West. Numbers such American Samoa 1 2 3 4 5 456, or 9999 are used because they are easy to remember.
Who developed the 2 alternatives to Euclidean geometry?
Hyperbolic geometry was first announced by Russian mathematician Nikolai Ivanovich Lobachevsky, 1792–1856, also seen as Lobachevsky. In 1826, he challenged Euclid's fifth postulate that one and only one line parallel to a given line can be drawn through a fixed point external to the line. Instead, he developed a self-consistent system of geometry in which the flawed postulate was replaced by one allowing more than one parallel through the fixed point. This idea was already developed independently by Hungarian János, or Johann Bolyai, 1802–1860, in 1823, after several attempts to prove the Euclidean parallel postulate. He developed his system by assuming that a geometry could be constructed without the parallel postulate. And German mathematician, physicist, and astronomer Carl Friedrich Gauss, 1777–1855, also seen as Johann Carl or Carl Friedrich Gauss. In 1816. But, as often happens in science and mathematics, the person who publishes an idea first gets most of the credit. This time, Lobachevsky was the first to publish.
What is algebra?
Depending on whether one is a student or professional mathematician, the word can mean either of the following, both of which are further described elsewhere in this chapter. School algebra is what mathematicians refer to as the algebra we learn in middle and high school and call arithmetic. But for most people, algebra means solving polynomial equations with one or more variables. The solutions to such equations are often obtained by the operations of addition, subtraction, multiplication, division, raising to a power, and extracting a root. For more information about all these operations, see Math Basics. This also includes determining the properties of functions and graphs. But mathematicians use the word algebra most often in reference to the abstract study of number systems and operations within them, such as groups, rings, and invariant theory. This is called abstract algebra.
How are the shapes of crystals classified?
Geometry plays an important part in the study of minerals. This is because certain minerals exhibit specific shapes called crystals, with specific crystalline forms occurring when a mineral's atoms join in a particular pattern or internal structure. This arrangement is determined by several factors, including the chemistry and structure of the mineral's atoms, or even the environment in which the crystal grew. Overall, there are specific angles between corresponding faces of all crystals. Mineralogists, scientists who study minerals, divide these crystalline forms into 32 geometric classes of symmetry. They use this information to identify and classify certain minerals. The crystals are also subdivided into 7 systems on the basis of an imaginary straight line that passes through a crystal's center, or axis. The 7 groups include cubic, or isometric, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and trigonal, or rhombohedral. For example, a crystal in the cubic system has 3 axes that intersect at right angles. The axes are also of equal lengths. The best way to envision this crystal is to think of a box with equal sides or a cube.
What is a truth table?
A truth table is a two-dimensional array of truth values derived by determining the validity of arguments through assigning all possible combinations of truth values to the statements. This simple form of logic depends on a combination of certain statements. Using terms such as not or and, along with the input values. The first columns correspond to the possible input values and the last columns to the operations being performed. The rows list all possible combinations of true, t, or false, f, inputs, together with the corresponding outputs.
What is a decimal system?
The decimal system uses the base 10 notation system to represent real numbers. A decimal expansion is the expression of a number within the decimal system, such as 1, 15, 359, 18.7, and 3.14159. Each number within the system is called a decimal digit. Such decimal notation or a numbering notation based on decimals was first used in India around the year 594. The decimal point is represented by a period placed to the right of a unit's place in a decimal number. It is interesting to note that a comma is used in continental Europe to denote a decimal point, such as 3,25, translated as 3.25, which in this case would logically be called the decimal comma.
What was the Julian calendar?
By the time of Julius Caesar, 100 to 44 BCE, Roman calendar keeping was a mess. Caesar decided to reform the Roman calendar. Asking help from astronomer and mathematician Sosigenes of Alexandria, lived c. 1 BCE, not to be confused with Sosigenes the peripatetic c. 2nd century, an Egyptian philosopher. The year 46 BCE would consequently have 445 days, a time appropriately called the Year of Confusion. Sosigenes began the reformed year on January 1, 45 BCE, a year with 365 days, and proposed an additional day for every fourth year in February, leap day. The alternate months of the year, January, March, May, July, September, November, had 31 days, the other months would have 30 days. In the Julian calendar, there was only one rule: every year divisible by 4 was a leap year. The vain heir to Caesar, Augustus Caesar, 63 BCE 14 CE, aka Gaius Octavius, Octavian. Julius Caesar Octavianus, and Caesar Augustus, would change the Julian calendar in several ways. Not only did he name the month of August after himself, but he would change the number of days in many months to their present usage, adding more confusion to the calendar. The Julian calendar would govern Caesar's part of the world until 1582. Not that the Julian year was perfect. A year's 364.25 days was too long by 11 minutes 12 seconds. Although the difference between today's measurement of the year and the Julian year was not great, it adds up to 7.8 days over 1,000 years. But as with many decrees and mandates, Caesar, Sosigenes, and Octavian left it up to future generations to fix the problem.
How do civil engineers use mathematics?
Although most civil engineers actually spend only a small portion of their time doing calculations, mathematics is essential to this field. For example, civil engineers may use math to carry out the technical calculations in order to plan a construction project. They may use math to model and simulate the possible behavior of a structure before it is actually built. They also use math to understand the necessary chemistry, the strength of a material, and or physical components, how strong parts need to be, of a construction project.
What are the addition rules of probability?
In probability theory, the addition rule is used to determine the probability of events A or B occurring. The notation is most commonly seen in terms of sets: P, AUB, equals P, A, plus P, B, P, AB, in which P, A, represents the probability that event A will occur, P, B, represents the probability that event B will occur, and P, AUB, is translated as the probability that event A or event B will occur. For example, if we wanted to find the probability of drawing a queen, A, or a diamond, B, from a card deck in a single draw, and since we know there are 4 queens and 13 diamond cards in the deck of 52, the equation and resulting probability becomes 4 50-seconds plus 13 50-seconds. 1 50-second equals 16 50-seconds. The 1 50-second is derived by multiplying 4 50-seconds x 13 50-seconds. But there are also rules of addition for mutually exclusive and independent events. For mutually exclusive events, or events that can't occur together, the addition rule reduces to P, AUB, equals P, A, plus P, B. For independent events, or those that have no influence on each other, the addition rule reduces to P, AUB, equals P, A, plus P, B, P, A, P, B.
What is a solar-based calendar?
A solar-based calendar is one based on the apparent movement of the Sun across the sky as we orbit around our star.
Can Newton's three laws be expressed mathematically?
Yes, Newton's three laws are all based on mathematical formulas. But the equations would be too complex for this text. They are defined, some with applicable mathematical notation, as follows: Newton's first law. Law of inertia, states that without any forces acting on an object, it will maintain a constant velocity. In other words, an object will stay still or keep moving in a straight line until something pushes it to change its speed or direction. The one force that stops almost everything from standing completely still or moving in a straight line is gravity. This is easily seen when you throw a baseball in the air. The ball does not move in one continuous, straight direction because the Earth's gravity pulls it downward toward the surface. Newton's second law, law of constant acceleration, states that if a force acts on an object, the object accelerates in the direction of the force. The force creates an acceleration proportional to the force, and inversely proportional to the mass. This is written in the following notation: F equals ma, in which F is the force, m is the mass, and a is the acceleration. Newton actually expressed this in terms of the calculus, a form of mathematics he created to explain these physical laws. For more about the calculus and Newton, see History of Mathematics and Mathematical Analysis. Newton's third law, or law of conservation of momentum, states that forces on an object are always mutual. To put it another way, if a force is exerted on an object, the object reacts with an equal and opposite force on the phenomenon that initially exerted the force. Simply stated, objects exert equal but opposite forces on each other. This is often phrased, for every action, there is an equal and opposite reaction. The mathematical equations for these forces are complex and beyond the scope of this text.
What was the original use of Stonehenge?
One of the most famous ancient stone complexes is England's Stonehenge. An impressive engineering and mathematical feat. Several groups of local inhabitants constructed this collection of large and small stones grouped in 4 concentric circles, 2 of which are created by paired upright stones bearing huge capstones between 2950 and 1600 BCE. Based on how the stones line up with various astronomical events, historians believe the entire structure represents a huge, literally monumental, calendar. For example, various stones align with the moon, the full moon's extreme positions on The horizon are marked at Stonehenge, and with the sun, including the summer solstice. It is also thought that the complex served as a place in which ancient rites and rituals were performed on significant days of the year. And it was all built without the help of computers.
What is a quantifier in predicate calculus?
A sentence or many sentences containing a variable, such as x, can be made into true or false propositions simply by using a quantifier. The quantifier actually assigns a truth value to the sentence. Depending on the set of values allowed for that variable. There are two major quantifiers, the existential and universal quantifiers, which are represented by the logical operator symbols of 3 and v, respectively. Although there are also more exotic types of logic that use different quantifiers.
What is a sample in statistics?
A sample is a generalization about a population and is represented by a group of units selected from the population, also called a subset of the population. The sample is meant to be representative of the population. Thus, in many studies, there are many possible samples. There are also types of samples, such as a matched sample, in which two of the members are paired. An example would be the IQ of twins. There is often a good reason for taking samples of a population. Most of the time, a population is too large to study as a whole. For example, take the smaller example of the above population of 10 cats. Again, none of them are identical, but certain common features between the cats can be measured, including color, fur length, and weight. If data is collected about the fur length of the 10 cats, the population, then if we chose only to take the cats with long fur, that would be a sampling. Another example is the population for a study of physical condition of all children born in the United States in the 1970s. The sample could be all children born on July 5 in any of those years.
How are mathematics and the study of time connected?
Mathematics is definitely tied to time. There has long been a need in human civilizations to record many sequences of events, especially those in nature that affected people. For example, the changing of the seasons was important to know, as it influenced the planting and growing of crops, when rivers would flood, and even when weather would change from monsoon rains and harsh droughts to potential blizzards. The first such timekeepers counted the changing days and years by the movement of stars, the sun, and the moon across the sky, all of which are activities that included simple mathematical calculations.
What is a placeholder?
A placeholder is a number that, as the name implies, holds a place. Initially, various cultures used a placeholder, often a dot or a space, to show an empty spot or place not used in a numeral, or other way of counting. This was in place of what we now call a 0, 0. A symbol that is not only a placeholder but also an essential number in our numeration system. For more about the evolution of the symbol 00, see History of Mathematics.
How is the term inverse used in arithmetic operations?
Inverse operations are those that undo another operation. In particular, subtraction is the inverse of addition because a plus b equals a. Division is also the inverse operation to multiplication. The inverse of a number can be expressed as follows. The additive inverse of a real or complex number is the number that, when added to a, equals 0. In multiplication, the multiplicative inverse of a is the number that, when multiplied by a, equals 1.
How are degrees and radians translated?
When measuring the number of degrees in a circle, another unit called radians is often used in trigonometry. It is known that a circle is 360 degrees, with 1 degree equal to 60 minutes, 60. And 1 minute equal to 60 seconds, 60. This is also called DMS, degree minute second, notation.
What are truth values and truth functions?
As seen above, when discussing propositional calculus. A proposition is any declarative sentence that is either true, T, or false, F. Mathematicians refer to T or F as the truth value of the statement. The combinations of such statements are known as truth functions, with their true values determined from the overall true values of their contents. Truth functional analysis includes the following logical operators. Negation. The negation of a statement is false if the original statement is true, and true if the original statement is false. It refers to it is not the case that or simply not in natural language. Conjunction. The conjunction of two statements is true only if both are true and false in all other instances. It refers to and in natural language. Alteration. Alteration, or disjunction, of two statements is false only if both are false and true in all other instances. It refers to or, and either, or. In natural language, conditional. Conditional, or implication, is false only if the antecedent is true and the consequent is false, and is true in all other instances. It refers to if, then or implies in natural language. Biconditional. Biconditional, double implication or bi-implication, is true only if the two statements have the same value. Either true or false, it refers to if and only if. In natural language.
What are the 5 postulates of Euclid?
Euclid was also famous for his postulates, propositions, statements that are true without proof and deal with specific subject matter, such as the properties of geometric objects. For more information about postulates, see Foundations of Mathematics. Along with definitions, Euclid began his text elements with 5 postulates. These postulates are as follows, some of which may seem obvious to us now. But in Euclid's time they had yet to be formally recorded. It is possible to draw a straight line from any point to another point. It is possible to produce a finite straight line continuously in a straight line. It is possible to describe a circle with any center and radius. All right angles are equal to one another. Given any straight line and a point not on it, there exists one and only one straight line which passes through that point and never intersects the first line, no matter how far the lines are extended. Another way to say this is, one and only one line can be drawn through a point parallel to a given line. This is also called the parallel postulate. Mathematicians first believed this last postulate could be derived from the first 4. But they now consider it to be independent of the others. In fact, this postulate leads to Euclidean geometry, and eventually to many non-Euclidean geometries that are made possible by changing the assumption of this 5th postulate. Like many early attempts at explaining mathematics, not all these postulates tell the entire geometric story. There were still a large number of gaps, many of which were gradually filled in over time.
What are multiplication tables?
Multiplication tables are just what the name implies, a table of multiplication. Most of these tables have a specific purpose, mainly to multiply numbers in the rows and columns by each other to find a product. One of the simplest multiplication tables deals with the whole numbers.
What is an electronic calculator?
Most people nowadays are familiar with electronic calculators, small battery-powered digital electronic devices that perform simple arithmetic operations and are limited to handling numerical data. Data are entered using a small keypad on the face of the calculator. The output, or result, is most commonly a single number on an LCD, liquid crystal display, or other display. It took a long time to go from the electronic motor-driven mechanical calculator to the electronic calculator. In 1961, the company Sumlock Comptometer of England introduced the Anita. A new inspiration to arithmetic, the first electronic calculator.